rolled this potato chip.
I couldn't roll a potato chip if I tried.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm managing editor Tom Nardi.
This is episode 151. We're going to be talking about the Hackiest VR glove, plotting Boba Fett with shoelaces, ECU hacking, and where does ammonia come from? Tom, what is news this week?
Well, we're a little behind the ball, but it's not our fault. The official release went out New Year's Eve, and big surprise, it kind of got missed by a lot of people. And only this week, I think, as NASA's PR branch really picked up on it. But it's the White House's intent to fund the International Space Station until 2030, which is good
fantastic
news.
Yeah.
Right? It's not a huge surprise, at least on our side. It was expected that we were going to try to get some more science out of it. Big question now, of course, is what do all the other countries involved think, namely Russia? Things are not super great between us and the Russians currently, and the ISS is kind of like one of the last places where politics hasn't played too much of a part.
Oh.
I won't say
but
no
even
part.
there a little bit, right?
Right, a little bit of a part. More so in the last couple of years, but as of recording this right now, there doesn't appear to be a Russian response to the White House's plan. There is no space station without the Russians, really.
You don't think? We don't think we could just unscrew their modules and run our bit?
I've often heard it say that they can do that.
Oh.
But yeah, because the core Russian modules are responsible for movement and guidance and that kind of stuff. They were the first ones to go up, so those were the ones with the thrusters and that kind of stuff. So it's often been said that they could pull their modules off and start their own much smaller station, whereas we would be kind of dead in the water with just the rest of the country's contributions. All the other countries were, not to discredit their modules, but most of them are like passive laboratory modules or sleeping quarters and that kind of
modules.
stuff. Right.
Yeah.
They're not equipped to run the whole space station,
Right.
But on the other hand, the Russians just put a new module on not that long ago. So, you don't do that unless you're planning to stick around for a while. So
unless you're planning to build enough up there,
well,
use what we got now for staging. Put enough together that you could totally go autarkic, and then just unscrew and.
All right. Well, so yeah, maybe that's
off.
not the positive development we hoped for. Their official line is that they feel that the core modules are getting too old now. I mean, they put them up in 2000, 2001, something like that. There's a lot of miles on there. They're highway miles, but still, it adds up. Like I said, those are the core modules too. So it's not like you can say, screw it. You kind of need the core of the space station.
Right.
But we'll see. I mean, it's good for like American companies, certainly, the extension, because I mean, you look at somebody like Boeing, who still has yet to get to the space station. They had have X amount of flights that were contracted, and I think last time I wrote about it, it was getting kind of tight. Whereas like, are you really gonna be able to fit these many flights in if we're talking about 2024 or 2026, end of life? So now that we're running until 2030. It'll give more companies, commercial companies, a chance to get up there and do flights, which is always cool for competition.
The other big news this week is a little bit of schadenfreude from us. This is Canon can't get enough toner chips, and so it's instructing customers how to defeat its DRM that it put on them to make you buy more toner. And I think that's absolutely lovely. Because, we've all known that this kind of use of DRM and use of the DMCA to claim that this is a copyright violation has been, I don't know, questionable at best and certainly anti-consumer. And so it's really awesome to see them in a position where they actually have to admit they don't have to worry about this DRM that supposedly was supposed to protect you from, I don't know what, counterfeit ink cartridges.
I think they're real lucky that in the end, defeating the DRM in this case was literally just hitting like okay on the little screen, because it comes up and says like, oh, there's something wrong with this. It could have easily refused to print, but they had the I guess the forethought to make it so you can back out.
Then
that
would
have
have
really been a disaster.
Really been up the creek. Yeah, true.
Like imagine
true.
having to push a firmware update out just because you couldn't get the chips to put in your own cartridges, right?
Exactly.
They do mention that there's no negative effects on the print quality, but like I think you can't tell. It won't tell how much toner is in the cartridges and that kind of stuff. So I mean, you do lose some. You can print. That's the important thing, right? You can print, but you won't get all the functionality. So I guess that's their argument. Like, oh, I see. If we didn't have these little chips in there, you don't have the same user experience.
It's funny to see them having to do this. I wonder if this is always going to work. Do you think forever from now on we'll always be able to just hit OK and run whatever inkjet printer cartridges we want?
I would say this has probably scared them
Is the
to ever put a hard stop on non-chipped cartridges, right? Like,
yeah.
Since they've had to do it once, I don't know. Like, you'd be pretty foolish to then go forward and be like, I know what I'm going to do. I'm going to make it so
that's right. Let's double down.
Let's double down on this failure.
Yeah. Yeah. I wonder. Well, I wonder if the cat's out of the bag. We'll see what happens.
This is a journey into sound.
What's that sound?
What's that sound?
It's time for our drawing from last week's What's That Sound? This one was an outrageous success. I think my clue, Tom, was too easy, right?
Too much of a clue?
Was that too much to say?
I will say it is the only reason I got it. Without that, I would not have. It was too, for me. I don't have the trained ear, though.
The device in question was a sewing machine, and without that clue, I think it's just like, more clattery machine noise, right? So I had to give a little bit of a hint, but the result is that 38 people got the answer right out of something like 44, 45 submissions. So good for all y'all. And even better, people submitted finally some ridiculous nicknames, including I put Sriracha on my toast, son of a quilter, Bittelschieber, who is Swiss, I guess, Manifest Stephanie. That's a good one.
Oh, wow.
Shockingly,
Wow.
It's Jim, and bringing up the rear, Nom Tardy,
Oh, boy.
which I thought you'd like. Anyway, it's time to roll the dice. We got 38 winners. I am picking it this week with Python. I'm running random choice, and I'm doing it on a range. So I'm doing range 1 to 39, which gives us the numbers 1 to 38 inclusive. And then I'm using the random choice function, which picks a random member out of a set. And it is picking 4. That's a low number. Oh, best answer. Congratulations, Alec Dickman. Best answer, an electromechanical thumb stabber. And in parentheses, industrial sewing machine. Congratulations, Alex. We'll contact you about your t-shirt size. And the rest of you, stay tuned for next week. We'll do this again. So on with the show. My first hack this week is from Lucas Lucid VR. Low-cost haptic VR gloves work with hacked Steam games. This is a fantastic VR hack. It's a budget VR hack. This is looking like kind of 15 or 20 bucks per glove for haptic feedback VR gloves. How does he do this on such a budget, you might ask? By clever hacking design. The gloves themselves are, granted, a little bit unwieldy, but they get the job done. And what they've got is strings that go over the top of your knuckles and will hold your fingers and keep them from gripping to provide the haptic feedback in question. So like you grab a handrail and it tightens up, preventing your hand from grabbing tighter than the diameter of that handrail, for instance. It works by having these strings go over the top of your fingers, and they are pulled into take-up reels, which are the little badge extension holder things, those badge reel springy things. Awesome. That run to your fingers. But they don't serve any purpose other than to pull the slack up when you straighten your fingers out. What makes the resistance are a bunch of cheap hobby servo motors. I think he's using like MG90s, the little Metal Gear hobby servo motors. And they interact with a screw driven into the badge holder, and they just stop it from extending anymore. So the code that's on a microcontroller on the glove then tells each one of the servo motors to stop the spool from retracting beyond a certain point. That pulls the string. You can't curl your hand up any further, and you feel like there's an object in your hand. he has a guest try this out on his video, and he is completely astounded by this. My guess is it works a lot better than you'd expect. And part of that's because Lucas went through a bunch of revisions here, and the one he's showing off in this video and this Hackaday IO project is, I think, his 5th or 6th revision. And so it's really refined a little bit and displays some super nice 3D printing work because, for instance, the part where the glove thing straps on your wrist has to be nice and solid because you're pulling against it with your fingers. And so an original version was kind of elastic banded on, but then that gave a springy feel to everything because your fingers could pull against the elastic band. This current version has a solid 3D printed plastic collar and reportedly gives a lot better feedback.
I know I said something similar last week with the ping pong ball array, but this is like, if you've ever wondered, like, is there really a reason for the individual to have a 3D printer? Just look at this project. I mean, I defy you to figure out how you would have done this otherwise. You know, there's so many intricate 3D printed parts. The design is phenomenal. Maybe some of them you could have sourced elsewhere, but, you know, it would have been more expensive, more time consuming. I know Mike always used to say a force multiplier, right? Like the 3D printer is like a force multiplier. Like it probably would have been possible to do this without it, but the fact that, you know, you have access to that has made this thing possible. You know, really. Like I don't think we would have seen something so elaborate if you couldn't conjure up components to your specifications.
I guess we've talked only about the hardware so far. The other half of this hack is the Open Gloves driver, which Lucas and a friend of his wrote, that works with Steam VR. They then hack the games a little bit to work with the driver. And so far they've only hacked a few games to work with it, but that includes Half-Life Alyx, which is a game that's kind of controlled by invisible floating hands, and Boneworks, which is basically the same thing. These are two like very tactile games, and they've modified both of them so that they work with this glove system, and these will give you also kind of an idea of how to hack further games so that they can work with this Open Gloves driver, so that then they can work with a super cheap interface. And basically all the Open Gloves driver does is knows the shape of the physical object that is in your hand and then tells the servos all at which angles to move. And so it's a really cool piece of software that you can actually download from the Steam's open app thingus and use yourself. So this is a really cool and fairly complete project. It's a cheap project, and it's a really compelling project if you're into DIY virtual reality stuff. And if you are at all, you absolutely have to follow Lucas's Hackaday IO page and his YouTube channel, because he teases at the end of this that his next project is going to be a virtual reality treadmill.
Ooh.
And that is, as far as I'm concerned, kind of like one of the holy grails of virtual reality interaction, because it's one thing to kind of point in a direction and say, okay, now my virtual avatar is walking there. And it's another to actually be able to move your feet. But to do that, you need a 2D treadmill. And so I don't know. That's upping the ante very high. I'm interested to see how he'll pull that project off.
Holodeck, here we come, right? I'm very excited to see what the readers and listeners think about this next project from Jean Thomas, Boot to Arduino. When he sent it in, he said that it seemingly serves no purpose, but I think he was shortchanging himself a little bit. What we have here is essentially is an x86 core for Arduino, which means you can write code in the IDE just like if you're going to do for a microcontroller. But instead of flashing it to a chip, it creates a bootable floppy image. And you could boot that in an emulator, or you could put it on a floppy and put it in a computer. You know, I don't want people to get the impression, you know, this is like some little free DOS environment that boots up and then runs like a C program. Like, your code is it. Like, that's all that's running. You've essentially turned your computer into a big Arduino. There's no overhead. There's no operating system. Your code has full control. And, you know, in the project, you have a few demos, obviously, you know, the Hello World, right? But there's one where it's a little digital piano. You know, you hit the keys and it plays tones.
Right.
And, it kind of stops there. And he says, oh, this is like a cute little project. I don't know what to do with it. To me, and, I mean, this is where I'm interested in what other people think. I thought this had potentially huge impact for retro computing, because I think it's really cool that you can use, a modern environment to write code that could boot on, I would imagine, a very low-end machine, since there's very little overhead involved, The Arduino core he's come up is pretty limited, at least at the moment. It can, it can show text on the screen. It can read from the keyboard. It can play tones on the speaker. I think, looking at the code, I think that's pretty much it right now. But to me, that's all you need for a lot of these early text games, right? I mean, you could port over all kinds of stuff with just text input output and the occasional bleeps and bloops. So I would really like to see not just games, but, even potentially different tools and utilities on these, bootable disks that you could put into some ancient machine and get some life out of. So I really do hope that somebody out there, tries to, implement Zork or something with this and see how low you can go. I'd be very curious, where the limits are for this core that he's written for Arduino.
That's funny. I was thinking of it in kind of the opposite way of like really trying to turn your big computer into just a microcontroller. And for me, that means like all of the peripherals. And so the libraries that he hasn't implemented yet, like the wire and like the I2C libs and the servo control libraries and stuff, those are the ones that I'm missing, right? Like those are the ones that I think would be cool.
Oh, sure.
I guess most laptops have I2C in them, so it's not at all impossible. And what I think is really crazy cool about this is that I went looking through the code to kind of see how it works. And like a good percentage of it is x86 assembler. And I was like, oh yeah, well, of course it has to be. This is then running on, a bare metal x86 right after boot up. This is code that has to be like written in x86. And I'm thinking, what he's really done here? Arduino is kind of like this ultra minimalist microcontroller operating system. This is really just the hello world of operating systems.
Yeah.
For an x86 machine, basically.
Obviously, more features are always better, right? Like, you're right. It'd be cool to get, file access, at least would be huge, right? Like that, yeah. But, hopefully if there is some interest and people start experimenting with it, we'll see some additional, functionality added. It's a pretty good example if you're looking to make an Arduino core for something else too. You could kind of look through here. I did the same thing you did. Checked out like the the assembly code. It's pretty bare bones. So if you're looking to port Arduino maybe to something else, it could be a good reference point.
I still don't fully understand how the video stuff works. Did you dig into that at all?
It was not super obvious to me either.
Just doesn't look like there's enough stuff going on there to make characters on the screen.
Right.
Does this mean that like the x86 BIOS has these kind of super low level, this is how to just put characters on the screen? And I think the answer must be yes, right?
Yeah.
Because all the BIOSes in the world have, character screens that come up. They all come up in whatever 80 by 24 or whatever crappy low resolution Visa text mode. So that must be supported at some super low level, and that's what his video library is taking advantage of. I really need to learn about hacking on x86 machines.
Yeah, because it doesn't look like there's any kind of image support. It's all just text. And like you said, I think it even says like 60 by 24 or something in one of the things. It's about as low level output as you can get. But yeah, and that's kind of where I was curious too. Like where does compatibility break? How far back or how far forward, for that matter, can you go before it stops working? I'm in the demos. Like he shows it running in a software emulator, but he also it's on a ThinkPad, not like an ancient ThinkPad, relatively modernish. So I think that'd be really cool. It just establishing what like the compatibility is,
Yeah.
When I saw this project, I was like scrambling. Like, do I have some ancient thing with a working floppy drive that I can try to run on?
I think I can even boot up with this.
Yeah, and the other day, no, because I was like, I got USB floppy drives, but that's not really much of a test because you just got to be halfway decent to boot to that. So if anybody's listening and has, like a 386 handy,
please
let us know. Yeah, I know they do.
I bet you there's 100 people listening to this right now who have a 386 handy.
Yeah, I can hear them now, just like they're
I can
flexing
hear
their
them.
knuckles, ready to type their response.
I can hear the floppy drives whirring in the background. From a minimal software hack to a minimal hardware hack, my next one from Jim RD, Servo Plotter Needs Nothing Exotic, is a beautiful little weekend motor control experiment hack. It's a 2D plotter basically done all wrong. It's got an Arduino and a sensor shield to drive some servo motors. And if you normally think about how am I going to get nice long distance linear motion, you think, oh, I'll put some screws and some stepper motors on it, or stepper motors and gears and belts, or something reasonable. No, no, no. Jim has taken a bunch of servo motors, because that's what he had, and put essentially long arms on them. Attached to these long arms are then some solid push rods that then move the two linear axes, I guess the X and the Y, along some drawer slides, again, because it's what he has. Now, this is a crazy mechanism because the servos have to push these long arms, and so they've got all of the leverage working against them. And they have the world's most non-linear motion, because if you think about it, the servo motor moves, a certain degrees. It moves in, a certain angle forward and backwards. And then this pushes this push rod that makes actually kind of a triangle with the track underneath it. And so as you change the angle of one of the sides of this triangle, the bottom thing moves out by, I guess it's the length of the hypotenuse or something. The inverse kinematics in this is really tricky, and that's, I think, is part of the fun. Jim, instead of trying to do this all out with sines and cosines or, I guess, tangents, he does it by moving the plate a little bit and figuring out what the microseconds pulse to the servo motor would be to make it move a centimeter here. And then he does it again and he makes it move the next centimeter and the next centimeter. And he takes all of this kind of empirical motion control inverse kinematics data and runs it into an online polynomial solver and gets a polynomial out of this. Because remember, this is all running on an AVR 328 based Arduino. So he doesn't have spare computing power. And this is an awesome solution to that because he's got some kind of weird, horrible, transcendental function mapping between the servo angle and XY position that he gets out of his G code. And he's just doing it by using kind of an nth degree polynomial that's as close to that as possible. So that's a lovely hack, and it's one to keep in the back of your head when you've got some control problem where you just don't want to map it out. Just move it through the steps and figure out what the closest fitting function is. That's really cute.
Did you mention the shoelaces?
I haven't yet. Would you like to?
I feel like I was waiting. I was like, is he going to say the shoelaces? Is he going to say shoelaces? This is the Tony Stark built this in a cave with a box of scraps project of the week, and I love it. I'm sure I'm not alone when I do something. I take it too far. Like everything has to be like these perfect little things, and it takes me forever because I put so much thought into even the most worthless little nuance. But this is the way we should do it. Like he just throws it together and it works. Like there's wood screwed to like erector set pieces. There's all kinds of stuff here. There's shoelaces that seem to have like counterweights on them, I think, because they're like hanging off the table. I love the little servo that pulls a string to lift the pen off the paper. Like it's all so great. Like this is a guy who is not concerned about pushing all this to GitHub when he's done with it. Like this is, I want to draw Boba Fett and I want to do it now.
That's right.
Where are my shoelaces and servos? I think in the video, he's like, at one point, he's like, I already had all this. All I had to do was go to the store and get the drawer slide. So he's like, this cost me like $6. So, I mean, for $6, it's a pretty good plotter. I can't deny it.
That's right. This is the machine you build with whatever's sitting around. And if you don't have exactly what's sitting around by him, this may not be the machine you'd build, but it's lovely to see.
Yeah.
It does enable him to do this kind of like full stack machine design, from putting strings and counterweights on it to work some of the slack out, to doing the kinematics design. He actually uses a really neat program that I'd never seen before called DrawingBot V3. I'll throw the links in the show notes, which takes line drawings and turns them into G code. But then that means he has to write essentially his own G code to whatever these funny servo positions are, decoder for the machine. And so he does that for the Arduino. He gets an excuse to take every step along the way and do it all himself. And then the output is this kind of super wiggly picture of Boba Fett, because there is slack and wiggle and play everywhere in this machine. But what he wants to do with it in the end anyway is paint over it. And so the art that comes out of this is this kind of weird, janky machine coupled with human painting work over the top of it. And it actually ends up looking really good. And I think it looks better than it would look if he had like the most clinically precise drawbot in the world doing it anyway. So it's this lovely, kind of, it's like in the Japanese wabi-sabi spirit. It's like just kind of slapped together and it becomes art because it's got this life in it, I guess. I don't know. Really, really fun. If you're looking for a pen plotter that's on the polar extreme from this, I absolutely have to recommend to you Bart Dring's Mid-T-Bot. We've written this up on Hackaday. I'll throw the links in the show notes. This one is a super small desktop machine, but Bart has engineered the heck out of this machine, and it makes the world's most precise, straight, and controlled pen plotter lines I've ever seen. If you just watch the video of it working, it is astounding. And he has, of course, the code for it. He's written his own branch of ESP32 Gerbil, runs in the behind the scenes, and he's got a marvelous and easy to 3D print design. So if you are on the opposite end of the spectrum from the just grab some hinges and some string, that would be the one to have a look at for you.
It almost makes me wonder if drawer slides are like this hidden thing that we should be exploiting more often.
Oh, drawer slide? Yeah.
Because when he has them doubled up, he says they're actually pretty good. There's not like a lot of play in it. It's. I think a lot of it comes from just that single slide that's got the the pen on it. But when they're both parallel, he's like, it's actually surprisingly solid. So
yeah, the one drawer slide takes up the play out of the other one.
Yeah, I want to see somebody build like a 3D printer with only drawer slides.
Oh, we used to do that back in the day.
Oh, really?
Drawer slides are in some of the super old like wooden rep machines.
Oh, well, we could come full circle then.
Rep strap that people used to build back in the day. And actually, you'll see a lot of them these days. There's a RC Keith. There's a super popular design for a foam cutter for remote controlled airplanes, basically for cutting out wing shapes. And it's a 4-dimensional hot wire foam cutter design. And it's all based on drawer slides too.
Well, from shoelaces and drawer slides to slightly more refined design, this 3D printed wind sensor. It detects the direction, and if you think about, the traditional way to do that, there's all kinds of reed switches and magnets and traces and bushings. The idea of having something spin is always tricky, right? The design that Martin has come up with is basically a 3D printed disc with carefully plotted slots in it and some photo transistors. And with just that, you're able to achieve about a 12-degree resolution because you can plot, which sensors are covered and which ones are open because what's on the disc. And as a wind direction sensor, it's phenomenal, right? I mean, it's really cool. I'm kind of tempted to print one myself. But in the write-up, Brian Flowers talks about like this. There must be other applications for such like a simple encoder that is very robust, has no parts to corrode or anything. It's just light and a specially made disc. So I'd really like to see what other kind of applications people can come up with this. If there's a couple of things like mentioned in the comments as always. But it's just a really cool, really robust design, and it's another one of those things where That just makes me want to start printing it out. I'll print it out and I'll figure out what I need it for later, right? Like once I have it in hand, I'm sure the rest of the weather station won't be far behind.
That's right. No, and when I read this, the first thing that comes into my mind is like one of these gray code type things where you have the sensors set out like along the radius of the wheel and different sliding holes move over the top of them. But this is actually something different. This is 5, in this case, sensors set out in a ring, and it's the lengths, like Tom said, it's the lengths of the gaps that make different codes for each position. And that's actually a kind of encoding I'd never seen before. And for this application is super brilliant because it's, like you say, it's non-contact. It's just light. So there's no friction. There's no mechanical wear. All of that is settled. It's really, really super clever. In this case, he's got like 5 light sensors. So in principle, if you optimally cut your holes, you could get a 5-bit position sensor. So it can tell, which one of 32 different orientations it's pointing in. That's plenty if all you're looking for is like north by northwest or whatever.
There's a really cool animation that we have on the page too that
explains
helps a lot.
all.
Yeah, it's a nice like top-down view, and you can see it like as the different light sensors are exposed. You get different binary coming out of it. Someone in the comments pointed to a commercial one that's not entirely unlike this. It's got I guess a little ball inside, and the ball is painted alternate black and white, and when the ball spins, the photo sensor it's like a tachometer, so you could do speed. But they said that the black and white lines are in kind of a sine wave. So not only do you get speed, but as the ball rotates the other way, the duty cycle changes. So it's able to get speed and direction by just watching, the ball spin, which is cool. I mean, when you're doing stuff for weather stations or anything like in the marine environment, like these are great design traits to have. Like you don't want to have little points to get corroded or anything like that. So if you could watch a ball spin or watch a disc spin and just kind of passively get the information, like that's going to last a lot longer than anything, like a little motor with a propeller on it or something.
Hands down, the most complicated hack this week is Willem Melching's VW Power Steering Reverse Engineering, aka Baby Steps Toward DIY Autonomous Driving VW Golf Edition. This is a really neat piece of work because he is working on converting the electronic steering mechanism of a VW Golf that is not meant to do autonomous driving so that it can. And what results from this is basically a crash course in ECU hacking. Now, the problem in particular here is that the VW Golf will only do limited automatic lane holding for 6 minutes, and then it needs a minute off. And it will only do this under 50 kilometers per hour. So that means that you can't use the steering mechanism to run your own open source autonomous driving firmware on the car. And this is where you should be warned that Willem works for Comma AI, which is GeoHot's open source AI for cars company. And so this is not his first rodeo hacking on cars, and it shows in this. But the basic problem is actually pretty easy. He just needs to find where these two functions are in the ECU's firmware and fix them somehow. This starts off as most car hacking projects do, which is step 1 is buy some used parts so that you don't have to use the parts of your car to hack on, because you're gonna brick the ECU anyway. You might as well brick a cheap one you bought off of eBay. Second, and this was the part that was entirely stunning to me, honestly, is that his second step was to get schematics of the ECU from the car manufacturer. And it turns out that most of the car manufacturers will offer you a 1-day subscription to their online service manuals and indeed schematics for the ECUs for not all that much money. And so he just ordered these up and boom, he knows where all the pins go. After this, it's a matter of basically hacking. He has to get in on the CAN bus. He has to brute force the password that flips the thing into diagnostics mode. There's a really cute trick here. He knows one password, but not the diagnostics mode password. And it turns out that the diagnostics mode password has a lockout on it. So if you guess wrong 3 times, it won't let you guess again for 10 minutes, which would totally thwart his brute force attempt. Except if you use the other mode, if you enter the other mode correctly, the one for which he does have the password, it resets this timer. And so he does this trick of trying to brute force this one and then alternately logging in with the password he knows, then guessing again at the one he doesn't, logging in with the one he knows, and it prevents it from ever locking out. Really cute. Once in diagnostics mode, I guess you want to dump the memory, or the alternative is you can use the update file for the car's ECU, which you can probably find on the internet again, and then you've got a binary you can hack at. Here, the hack involved fixing this lockout every 6 minutes, and he couldn't change the 6-minute duration to be like infinite, but what he could do was change the lockout duration to be 1/100th of a second. So instead of locking out for like 1 minute every 6 minutes, it now locks out for an imperceivable 100th of a second every 6 minutes, which is a cute hack. And the 50-kilometer-an-hour limit was simple enough to completely get rid of. In the end, the hack is just these 2 numbers in the ECU's firmware. But what's important here about being able to dump the ECU's firmware off of a test model is that then you can make sure that only these 2 bits have changed between the firmware you're preparing to upload into your car and what you know the firmware should be. And so he does that, puts it in. Oh yeah, he has to hack the bootloader. There's a whole post on hacking the bootloader, puts it into the car and wins. This is not a simple hack, folks. And it's not a low stakes hack, but it's a really cool one to be able to see how it's done.
Regular listeners may recall that last week I was very impressed with somebody patching a new function into their water cooler. This is actually very, very similar, except, you get in the water cooler and drive it down the street at the end. But, we had talked about how a lot of those kind of concepts are applicable to a wider array of projects. And I was reminded a lot of that one as I was reading through this, because there's a lot of the same steps. You're pulling the firmware, you open it in Ghidra, you're looking for places to patch in different stuff. I mean, obviously this was a far more complicated project, but it is interesting to see some of those kind of themes pop back up, so it's like baby steps, right? You get the router, then you get the water cooler, and at some point you're hacking your own car's ECM. I was also kind of surprised that this kind of capability was in a 2010 car. I don't know, maybe I'm just behind the ball, but like when he said it was a 2010, I was like, wow, they had that kind of thing, and I don't have that. Yeah, I mean, super, super impressive. I mean, this is phenomenal stuff. Like the guy in the comments said last time, these are the projects I come to Hackaday for. I also like to note in the little animated image we have on the page, he appears to be steering the car with the same joystick I used to play Kerbal Space Program. So, just to put our relative accomplishments in comparison, I suddenly feel quite inadequate. Now, I'll admit this is one that I may have misjudged on first glance, and I had to come back and look at. I love the title, This Little Minecraft Cart of Mine. It is a guy who made a little electric Minecraft cart, right? And at first glance, I said, okay, fine, you made a go-kart, and it looks like a Minecraft cart. Take your click and be gone. But then, at the urging of my daughter, who who found this very enthralling, I looked at it again, and I realized it's actually a cart, like a real minecart. It's riding a track. And it occurred to me, I don't think, and I'm sure people will rush to correct me in the comments, but I don't think we've ever seen many tracked human conveying projects on Hackaday that literally ride a track. To show how little like prior art there is for this kind of thing, really the biggest detail about the build was when it came time to figure out the wheels, they didn't know what to do because they couldn't find anybody else who had made an actual little minecart. So, buying them, they said was not going to happen because of cost, and you could turn down some wheels, right, if you have big enough stock, but I guess the diameter required, that was kind of a non-starter. They looked at like doing 2 wheels to hug the rail, and that worked, but only on like the smooth, unperturbed sections. As soon as there was like any kind of switches or anything, it would jump off. So in the end, they used, I think, brake drums. Yeah, they got brake drums, and they said that shape was more or less compatible with the rail. Not perfectly. If you watch the video, they pop off the rail quite a few times. If trains popped off the rails nearly as much as this minecart did, we'd be in a lot of trouble. There's one part where a twig, I don't even want to say a stick, an actual twig, like smaller than your finger, derails this thing and almost severely injures our intrepid rider, but luckily they got it back on the rails. But I just thought it was a pretty interesting look at a problem we don't often see addressed. How do you make a little rail cart? I also thought it was interesting that they found a disused section of like small rail. They said it was like an amusement park or something that had this like elaborate train system. And they asked, and they're like, "Yeah, sure, come and drive your little minecart on our rails."
That's actually the hardest part of the hack, as far as I'm concerned.
Right. Finding
yourself some rails to drive on.
Even if you built the thing, where do you go with it,
Yeah. No, you can learn a lot about the design of train wheels here, and it's really funny I didn't know any of this. I'm not a train nerd, but if you think about locomotive wheels, they're not flat on the rails. They kind of are beveled out so that they kind of automatically center, and they have these flanges that keep them from derailing and stuff. There's a lot of tech here that you can play around with and learn if you need to make yourself a minecart. I will say, I've seen one hack, and I was looking for links on Hackaday for it.
I did hear furious typing as I was saying. I don't think we've ever seen this before.
I actually have seen a hacker rail vehicle, and in particular at 2019 CCC camp, they were doing it at an old industrial brick-making factory, and they had rails all around the place. They're exactly the same width as those hoverboard scooters.
That's convenient.
It was super convenient. And one of the best, I wish I could remember who it was, but he had hooked up a cart driven by a hoverboard, and he had rigged up a hammock on a hoverboard cart and was driving around with the hammock or all around this track, which is cool enough, except he also had a camera on the front and a VR headset on his eyes. So he was actually lying fully back, relaxing, watching the FPV of his own little rail cart driving around on the tracks. But that is the only Hackaday rail hack I think I can remember seeing. And not very many. We need more rails around.
Yeah, right. That's the limiting factor. We need to have more rails so that we can build little rail carts. And I also like that, I guess the in-game speed is, they say, like 25 miles per hour, and he managed to exceed that, which is just...
danger.
Just like seeing how easily this thing came off the rails and to be going that fast. Man, my hat's off to him.
My first quick hack this week is Guy DuPont's Hit Clips custom cartridge hack will never give up, let down, or turn around. This is an awesome hack on an old gimmicky Tiger Tech early 2000s sound player that used to play a 60-second digital clip, and Guy, based on some earlier work by Choof Tech and others, has figured out the protocol, hooked it up to an SD card, and can now play entire albums in glorious 8-bit audio quality. Next up, Tent Heater provides comfort on a budget. This is a heater meant to provide you heat in emergencies, works on alcohol and other alcohol-containing fuels, designed by Heater Block. What's particularly neat about this is the kind of loop of copper that passes over the open flame, so preheats the alcohol gas, sending a jet out of the bottom, which then lights it up and keeps heating the copper tube that passes above it. This ends up with a very complete combustion, complete enough that you can run it inside a tent without worrying about carbon monoxide poisoning, And because it only works when it's pointed upright, if you knock it over, it extinguishes itself. So sweet design, cheap and easy, and their build instructions are quite complete. Please note that Hackaday's lawyers have informed me that we do not encourage running open flames inside tents. Last up, David at Usagi Electric makes basically everything out of tubes that can be made out of tubes, and even some things that can't. And this is the Atari Punk console, now made with more vacuum tubes. Basically, he's made not one, but two 555 timer IC clones entirely out of vacuum tubes, and combines them together to make the squeaky, squawky, introductory digital electronic synthesizer that everyone loves. This really appeals to me because on one side, these kind of audio purists are like, here's the vacuum tube amplifier that has, only even distortion and blah, 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 blah. And here's David saying, oh yeah, I'll make square waves with it and we'll make the thing squawk.
My first quick hack is digital rain animation crammed into a Pi Pico. Yes, there's a Matrix movie in theaters, so we're seeing a lot of digital rain effects, but as somebody who had that screensaver on his computer for about 10 years, I'm happy about it. This time it's on a Raspberry Pi Pico with a really cool little Pico display from Pimeroni on the front. The interesting thing is here that it took a little finagling with some Python scripts and some image editors to get all of the frames of animation at the necessary resolution onto the 2 megabyte flash of the Pi Pico. It looks great. It looks really accurate to the movie, but maybe the biggest takeaway is that you could load up other animations using the same technique if you wanted to make a little event badge or something like that showed a relatively short little video clip. Next up is Honda ignition coils sing the song of their people. This is the latest from Plasma Channel. We always like to see new videos from Jay and see what he's cooking with high voltage. This one takes the kind of classic automotive ignition coil with the 5.5 timer driver and modernizes it and puts it in sleek little acrylic cases. And the big hook this time is he's wired a Bluetooth audio receiver into the 555 timer, which lets him use it as a plasma speaker. Not a great one, it turns out, because ignition coils are not particularly well suited to running at those kind of frequencies. But it does work, as an added bonus, Jay hooks up an antenna to the spark gap and uses it as a radio transmitter. So if you want to really aggravate the people who live around you, this is a great project to work on, especially if they're avid radio listeners. This is in all forms not a hack, but I'm going to put it up anyway. Reusable booster rockets, Asian Roundup. Chris Lott wrote this up. When we write about the space program, it tends to be either NASA or SpaceX, and you can kind of get the impression that nothing's happening outside of the United States. And this is a good reminder that there are interesting developments all over the world, and a lot of them are dealing with reusable rockets, the next generation boosters. And it's just a quick rundown of like what's going on the other side of the globe, and some really interesting programs. Some have already got prototypes in place. Some have already blown up, so that's good, right? Like that's always the first step to developing a new rocket, is blowing some of them up. So it's just a really cool little rundown for the space aficionados in the audience.
And that brings us to our Can't Miss articles. These are long-form articles written by our Hackaday writers. And this week, I'm going to start off with Dan Maloney's Haber-Bosch and the Greening of Ammonia Production. I picked this one partly because it starts off with this like most poetic description of how we get nitrogen from the atmosphere into the ground, into the plants, and eventually into us. And before the Haber-Bosch process was invented, we would get nitrogen from a few plants, from bat guano, and that's about it. And clearly that is not going to support a world with as many people on it as we have now. So just around the beginning of the 20th century, the Haber-Bosch process figures out how to use natural gas to force the nitrogen from the air to hook up with some hydrogen and make ammonia. And that was the first time that humans could kind of make a synthetic fertilizer. And this really, literally changed everything. The global population went from 1 billion people to kind of 7 and a bit or whatever we've got now. And as Dan points out in the very beginning, we eat so much food that's a product of fertilizer. We're probably about 50% Haber-Bosch process ourselves by weight. So if you don't think this is important, it is. And if you think that this comes for free, you're wrong, because it's a big consumer of fossil fuels. And that's for 2 reasons. One is to get the spare hydrogens. Hydrogen's not just floating around everywhere. The other part that's really hard is to convince nitrogen, which wants to be in these really stable 2-atom molecules, to split apart and join up with these hydrogens. And that takes intense temperature and pressure. And so there's a lot of energy involved naturally, and 450 degrees C and 300 times atmospheric pressure. It's a tricky reaction to get it to go in the direction you want it to go. But that's easy enough to do if you've got a source of hydrogen coming from natural gas and you can burn it, which you can also do with natural gas, to get the heat. The problem is this is not a good way to do it in terms of CO2. And that brings up the Monash process, which is actually the secret star of the show. The idea is to look for some kind of electrolytic process to convince the nitrogens and hydrogens to hook up and form ammonia. And this looks like very promising research to do it. It works by making lithium nitrate. So it's got 3 lithiums and a nitrogen instead of 3 hydrogens and a nitrogen like ammonia. And then all you have to do is swap the lithiums out for hydrogen. People have been trying to figure out how to do this for a century. It's not as easy as I say. But it looks like through some very clever chemistry, some people have figured out a way to do this essentially at room temperature in a repeatable process with only electricity as the input. It's going to use a bunch of lithium, so if we're running into lithium shortages because of batteries, that could be a problem. But it gets rid of the entire CO2 burden of making fertilizer. And if you use solar power, for instance, to provide the electricity coming in, you don't even have to burn the natural gas to provide the energy either. So it's like win-win-win, and it looks like it's a lot less dangerous as well because there's no high temperatures and pressures. So it looks like it could be done on a small scale locally to where it's going to be used. So we'll see. This is all, of course, in research mode right now. Nothing is in production mode, and we'll have to see how it shakes out and if it can be successfully commercialized. But if it can, this could change something that's really kind of fundamental to the way we get and make food.
I gotta be honest. I didn't know a damn thing about this before I read this post. It was really eye-opening. And I like that Dan has kind of been on a roll with that, right? He's been kind of peeling back just these things that we take for granted. Like, I was blown away by this. Like, what are you talking about? All this nitrogen I'm eating comes from this process. And it used to come from where? Like you said, it literally depend on this stuff. The Earth couldn't support as many humans if it wasn't for this thing that I had no idea about. So, it makes you wonder all the other things that you're that you are completely oblivious to and that your whole life depends on. But Dan breaks it down really well, like he always does. And I do like how it kind of switches over halfway through, right, and turns into like, well, you thought that was cool. Well, check out this new thing we got. Like you said, there's still work to be done, but it's very, very, very promising stuff. It's really well done because had you just written about that, you wouldn't, like you wouldn't have. You needed that intro
chemistry article.
You needed that intro to explain like why is this very important, and then like why it's so significant that we can make these kind of improvements to a process that we rely on. As if we ever needed proof that the Hackaday readership operates on another level. I think the second comment is some guy's like, I've been working on a different version of this process myself. I have it on Hackaday IL. And sure enough, Sure enough, he does.
Of course.
It was even in the 2015 Hackaday prize.
Naturally.
And it has the page has 104,000 views. So I mean, he must be onto something, right? Like that's. Yeah. So he's got his own little home reactor using, and he says, "Hey, it's tough. It's tough." So I take it. I believe him.
Yeah,
I believe him when he says it's hard because he's doing it in his basement. I always look forward to these articles from Dan. I know he's got more coming, and I think it's just a really cool thing that we can expand on some of these topics that the average person just doesn't occur to them. I mean, I don't even think I never heard of any of this beforehand. So I'm glad on this day to not only write for Hackaday, but to read it also. So my pick this week is from Lewin Day. Does this lead make my car look fat? And I think for this one, we kind of have to explain, pull the curtain back a little bit on the Hackaday process. We don't assign anybody articles per se, but sometimes we see something cool and we say, hey, do we have anybody who wants to look deeper into this? And this one actually came from something I saw where, a guy wrote an article that said that Jeep put this crazy, 260-pound weight over the rear wheels back in the 50s because the Jeep had a tendency to go forward and throw its occupants out during braking if it didn't have more weight in the back. And that sounded like crazy to me. Like that's got to be some once in an industry hack, right? Nobody could ever do that. And we said, hey, Lewin, our local automobile expert, why don't you run with that? And run he did. He does talk about the Jeep in there, but that is, it turns out, just one of several examples. And I thought it was really interesting that for, the Jeep, it was all about getting the thing to stay on the ground, right? Like it wanted to lurch forward because the people are sitting front, the engine's front, the back is nothing really. So it would just kind of tip on its front wheel. So sure, add some weight into the back. But for some of these other examples, it's more about resonance and dampening vibrations and stuff. So especially like it says Porsche did this on some of their cars because they were designed for a 6-cylinder and then they put a 4-cylinder in there and the car was vibrating in a weird way. By adding just a few pounds in strategic places, they were able to dampen that. So it's really a fascinating look at like the little details that go into things that you wouldn't think, that there's little weights hidden under your fenders just because without it, the ride would be a little bit rougher. He goes into also talking about something that I really like. It says, engineers work hard to reduce noise, vibration, and harshness in new models known as in the industry as NVH. I love that. I'm going to start using NVH for some of my projects too, because noise, vibration, and harshness describes a lot of the things I work on. And I didn't know that there was like an industry standard term for it. So that was a really cool discovery from this article as well.
Well, that's going to be the next name for my next synthesizer project.
Yeah, that's
noise,
my band
vibration,
name.
And harshness. No, what I love about this is like one of these perfect storms because Lewin is both our gearhead and race car enthusiast. So of all people, he wants to make cars lighter, but he's also a mechanical engineer. And so his first paragraph taking this on seriously is really obvious in retrospect. And he says, anytime you add mass to a system, it changes its natural vibrational frequency. And so here you've got a damped system, a car on shocks, and it's got something producing vibration, and you just need to keep the whole rest of the car from vibrating along with it. Once you say that, this kind of paradox of why would you throw more weight on a car? That's a horrible idea especially for a sports car. It becomes actually kind of obvious. Although you do have to say that in the modern era, they do kind of design around these things from the get-go in a way that maybe they couldn't back in the olden days. And so some of this is probably newer tech. And when you get to the really new tech, there's mass dampeners. And I didn't know about this until reading this article, which is some vehicles, including a Dodge Ram truck and some Renault Formula One cars, have masses that are on motors. And like they do with noise-canceling headphones, they wiggle the mass in opposition to the vibration that they want to cancel out. And so they've actually got this like active noise/vibration canceling device that has a lot of mass and just shakes around at exactly the right inverse frequency to cancel out how the car's shaking around. And if you read one of Lewin's previous articles on Formula One racing, you'll of course realize that this revolutionary technology was ruled to be against the rules because it gave them far too much of an advantage, and they could only pull it off for a couple years.
Yeah, it is a good point. It's, looking at his examples, and I mean, not to say he has an encyclopedic knowledge of all vehicles that ever had weird little weights in them, but it does seem like they kind of stopped in the 90s, so I guess more modern technology, it's not that big a deal. It was, I mean, definitely a lot of these examples come from 60s and 70s.
Yeah.
And I think he mentioned somewhere in there too, where it was like, fuel efficiency was no one's concern back then. So like,
that's right.
The 60s, they're like, yeah, just put some more weight on there. It'll be all right. We're only getting 6 miles to the gallon anyway. What's it matter?
That brings us to the end of this week's Hackaday podcast. If you enjoyed it or hated it, write us, editors@hackaday.com. If you've got tips for us, please let us know, tips@hackaday.com. And until next week,
keep on hacking.
What does that even mean? That is not a convincing statement. Good job, random number generator. See if I can get through. Wow, good. I'm in.
Hacker voice, I'm in.
Oh, hot diggity. Open a ticket. Submit a request. Hackaday.com is returning 503 error. Actively looking into your request with the highest priority.
Oh, the highest priority.
Oh, it works again. Yep, everything's working. Lovely.
Yay.